Hello students, today we are going to look at the real number system. Now I know you've seen the real number system before, but we are going to add a little bit to it in the 8th grade. So there are 5 types of numbers that you need to know in the real number system. And you have a little notes page in front of you that you're going to fill out, and I'm going to help you fill all of that out. So you're just going to copy down what I tell you, and maybe you can put some more examples and non-examples in there if you want to. Okay? So the first thing you need to know is what I write on the board, you write on your paper. Okay? Simple as that. Everything that I write up here, you write there on your paper, and you can pause if you need to, and take a little time if you need to. So here we go. The first type of number that you need to know in the real number system, the real number system is the numbers that we use in our world. Okay? The first type of number that you need to know is a natural number. It goes in that first blank because it starts with an N. Natural number, and I'm just going to use the hashtag for number instead of writing the word number, since the word numbers is already on there and it's saving ink and everything like that. A natural number are what we would refer to as counting numbers. Okay? Anything number that we would count by would be a natural number, and it starts with the number 1. So an example would be 1. Another example might be 2 or 3 or 4 and so on. Okay? Those would be examples of natural numbers. Now the non-examples. Non-example means an example that's not a natural number. So the non-examples would be something like 0. Because 0 is not a natural number. Okay? So the non-example could be 0. I should put non-example, 0.7, no decimals in the counting numbers, and no fractions. So those could be all things that are non-examples. The next type of number we're going to look at are whole numbers. That's what that W stands for, whole numbers. Okay? Whole numbers are what you would think is counting numbers, or natural numbers, except we add 0. So whole number is included, so we're going to put counting numbers in the description, counting numbers, and 0. Okay? Now, so one of the things that I sometimes do is I put a line through my 0. That helps me know it's a 0 and not the letter O. Just so you know that. Okay? So counting numbers and 0, those are whole numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up. We keep going and going and going. So some examples that you could put in there are 0, 1, 2, and whatever else you want to put there. 173 if you wanted to put that. Okay? Now the non-examples, and I'm just going to put non-x because it's already on there. Some non-examples would be like 3/4, because that's not a whole number, that's a fraction. 0.73, that's not a whole number, that's a decimal. And -5. -5 is not a whole number. It's a negative number. We'll get to that in a minute. Now the next type of number that we have in our real number system, after we have our natural numbers and then our whole numbers, well, the next set of numbers are integers. Integers, I-N-T-E-G-E-R-S. Integers are positive and negative whole numbers. I'll give you a minute to write that down. Integers are positive and negative whole numbers. Now the only integer that doesn't have a positive and a negative is 0. 0 is just 0. It's not positive 0, negative 0. It's just 0, nothing. But all the rest of them can be positive or negative. So for examples that we would put, we could put -7, -5, 0, 1, and 18. Those would all be examples of integers. Now, non-examples, I'll put that down here, would be something like -3/4. Even though it's negative, it's not a negative whole number. So it can't be an integer. Okay? Or 0.73. We've used that one a lot. That's a decimal. It's not a whole number, so it can't be an integer. Integers can only be whole numbers. Okay? And another one we could put is like the square root of 7. Now, if we calculated this out on the calculator, we would see that the square root of 7 does not have an answer that's a whole number. There's a big decimal to find the square root of 7. The square root's new to you? Great, we'll learn about those later. Now, the fourth type of number that we have in the real number system are rational numbers. And that's the one that starts with R, rational numbers. Okay? Now, the description for a rational number is kind of long, but not too long. The description is any number that can be written as a fraction. Okay? So if I can take any number and I can write it as a fraction, then that makes it a rational number. Now there are some obvious examples. Fractions. Any fraction is a rational number. Okay? So for instance, I could put 3/4. Or I could put 9/5. Even though it's an improper fraction, it's still a rational number because it's still a fraction. Okay? But I could also put the number 3. Can I write the number 3 as a fraction? Of course, you remember that you put 3 over 1, it becomes a fraction, that's still equal to 3. So 3 over 1 is a rational number because I can write it as a fraction. Okay? So what about this one? What about 0.73? Is that a rational number? Can I change 0.73 to a fraction? Well, yes, because the 0.73 is actually 73 hundredths. So I can write 0.73 as a fraction, so that means it's rational. Those are all types of rational numbers. Okay? I can also make any of those negative. Okay? Negatives can be rational as well. So I could put a negative on any of those, but let's just say negative 0.73 and negative 3, because all of those are can still be written as a fraction, so that makes them rational. Now some non-examples. Non-examples of rational numbers, things that are not rational numbers. Well, I said that whole thing about the square root of 7. We'll look at that on the calculator later on, but when I do the square root of 7, it never stops. The decimal keeps going and going and going, and it never stops, and you can't write that as a fraction. Another one is that one. Remember what that is? Exactly. It's one of my favorite desserts, pi. Okay? Pi is 3.1415, yada, 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 yada. There's lots of numbers after. It never stops. And because you can't write that as a fraction, it is not a rational number. So those are two non-examples of rational numbers. And our last set of numbers in the real number system are, have you noticed that I touch my glasses at the beginning of every part? Kind of crazy, I know. Anyway, the last set of numbers in the real number system are irrational numbers. So that's IRRATIONAL, irrational numbers. Okay? Here is the description of an irrational number. It's going to look a lot like the last one. Any number that can't, and I'm going to capitalize can't, be written as a fraction. So you're probably thinking, well, we just looked at some numbers that couldn't be written as fractions, so those must be irrational numbers. You're exactly right. What were they? Sure were. One example is the square root of 7. Okay? I can't make that into a fraction any day, anyhow. It's not. And the other one was pi. Pi keeps going and going and going. It keeps a decimal keeps going and going and going. It never stops. It never repeats. It is an irrational number. Okay? Those are the examples. Now the non-examples are going to look like all the other kinds of numbers. Okay? So for non-example, we could have negative 3/4. It can be written as a fraction, so it can't be irrational. We could also have negative 3. Or we could have 0. Or we could have 0.73. All of those are not irrational because they can be written as a fraction. Okay? 5 types of numbers. Natural numbers, whole numbers, integers, rational numbers, and irrational numbers. It's important to know what they are and what kind of numbers they are, because you'll need that in your next activity. The last part is going to put it all together, and you really don't have to write this down. Okay? So I'm going to draw a little diagram. Let's say that this right there is all of the real numbers. Okay? This is our real number system. Inside the real number system, there's this set of numbers over here on the side that are called irrational numbers. Okay? Those irrational numbers, they can be written as a fraction. They're a part, but they're all by themselves over on the side. Okay? Inside the real numbers, we had that big group of numbers that we called rational numbers. Remember, rational numbers were anything that you could write as a fraction. Well, I can write integers as a fraction. So integers is a type of rational number. So it goes inside the rational number box because every integer is also a rational number. And it's also a real number. Okay? But these, neither one are irrational. Forget that one. Okay? And inside the integers box, we have that group of numbers that we called whole numbers. Okay? Because every integer, I was going to say that wrong. Every whole number is also an integer. Because the whole numbers were 0, 1, 2, 3, 4, and you can put those in the integer box as well. So that's why we put that in whole number box inside the integers. And then finally, we have this small set of numbers that are called natural numbers. Natural numbers are also whole numbers. And they're also integers. And they're also rational numbers, which makes them real numbers. So if I give me a natural number, great, 3, we'll take 3. So if I put 3 down, 3 is a natural number, but I also could put 3 in the whole number box. And I could also put 3 in the integer box. And I could also put 3 in the rational box because I can make 3 into a fraction, like 9 over 3 or 12 over 4. Those are all there. But if I put it in the natural number box, notice that it's already in all of those other boxes. Oh, snap. The 3 is natural, but it's also whole because the natural's inside the whole, so that means 3 is in a whole number. And natural's inside the whole, which is inside integer, so 3 must be a whole number and an integer. And it's rational, so it's inside the rational box, so 3 must be a natural, whole, integer, and rational. It's all 4 of those, plus it's also a real number. The only thing it's not is irrational. You have now come to the end of this video. Congratulations.